In this topic, we'll put together all the different C-type declarations, arrays of different dimensions, pointers of varying types, etc., into one unified rule for creating types at any level of complexity in C or C++. Now, the rules for interpreting C-type declarations are befuddling even to some experienced programmers. The best programmers, however, would have no trouble, for instance, recognizing this as a double pointer to a function that accepts a pointer to a 5-element array or a 5-column two-dimensional array of integers and returns a pointer to a function that takes 2 floats and returns a pointer to an int. Well, okay, maybe they'd have to squint for a moment, but I made that one up from scratch in 30 seconds and I wrote the description as fast as I could type. You should be able to do the same once you understand how to read and write this stuff. Will you really encounter declarations that complex in practice? No, but you'll find ones perhaps half that complex, and if you can easily understand ones like this example, you'll never be intimidated, as all too many C experts are, by simpler practical ones. Once you understand the underlying rule, it's really not that hard. So, what's the magic rule? Well, there are several mutually equivalent ways to describe it, and each student finds different ones useful, so we'll do it from several different angles, starting with the one that's most likely to be useful. The first and probably best way to describe the rule is one I already hinted at in an earlier segment. Declarations mimic the structure of expressions that use the declared variable. Recall, for example, that one declares a pointer to an array of dim ints, as on line 34 of our sample program here, right there. This mimics the way you use the pointer. You first dereference with parentheses to override precedence, arriving at an array, and then you index it to finally get an int. Let's call this the expression recipe rule. Now, this rule has the odd effect of requiring parentheses in the declaration whenever they would be needed in the expression to override precedence. But this resolves what would otherwise be ambiguities in declarations. For instance, if we omit the parentheses from the pointer to array declaration, as we do, for instance, on line 35 here, we get a completely different type. Variable array of pointer isn't a pointer to an array of ints. It's an array of integer pointers, an array whose elements are pointers to ints. We can initialize it with the addresses of a few ints, if we like, so the elements have something to point to. Let's show that in the notes here, like that. Now, some C programmers simply memorize the two patterns, but that's a very limited approach. You can't memorize every possible type declaration. Instead, let's apply the expression recipe rule. Question 1. How would you use array of pointer to get to an int? Write the expression using parentheses only if you must. Coming back from a pause there. Well, what you do is index it first, right? It is an array after all. So maybe we'll pick the first one. And that would arrive at a pointer. And then you dereference the result of that to get an int. Star array of pointer bracket x, whatever x may be. Let's put an x in there. No parentheses are needed. Precedence naturally puts the index operation first. And that's exactly the form of the declaration, except that the x is replaced with the array dimension dim. All declarations follow this rule. 4 steps. 1. Write an expression on the variable performing operations in the right order to work from the variable down to an elementary type like int. Use a dereference for a pointer, an index for an array, and as we'll see in the next segment, parenthesized parameters for a function call. Step 2. Use parentheses as needed to override precedence, but no more than that. Rule 3. Revise the expression by replacing array indexes with the dimensions of the arrays in question. And as we'll see in a bit, replace function call parameters with their pure type, something we'll discuss. And then, step 4, stick the elemental type on the left of the revised expression, and you've got your declaration, including any needed parentheses. Now, for the record, this rule is actually wired directly into the C grammar. the grammatical structure of a declarator, which is what you put in declaration lists, mimics that of an expression using star, bracket, and parenthesis function call. Let's try a few more examples from the sample code here. Line 36 declares a double pointer to an array. Now, it might be tempting to do this by just slapping another star to the left of the single pointer declaration on line 34, but that's not following the rule. If we had a double pointer to an array, as in the diagram here, we'd dereference it twice to arrive at the array. So we'd write and then we'd index the result. And the double dereference would require parentheses to override precedence. And that's the pattern here on line 36, which is correct. Okay, if we had just slapped a star on the left of the original pointer to array declaration, then we'd have what appears on line 37. Now, viewed as an expression, that says to dereference once the inner star, then index, and then finally dereference again the outer star. Now, that implies, as the variable name suggests, a pointer to an array of pointers. As the diagram shows, this is the type of pointer we'd use to point to an array like array of pointer. Thus, to use that variable, we'd need to first dereference it to get the array. And then we'd index the array, but we would need parentheses first to make sure the star occurred before the index. Once we index the array, we'd have a simple pointer to an int, one of these elements, and then that in turn would need to be dereferenced in order to get to an int. Now, earlier I promised several alternate ways to look at the rules for declarations. Here are two others that students sometimes find useful. First, declaring the expression. In a sense, C declarations don't declare the type of a variable. They declare the type of an expression. A line like int star parenthesis star pointer to array of pointer bracket dim is not saying that pointer to array of pointer is a pointer to an array of integer pointers. It's saying that the entire expression, this whole thing, is an int. The int keyword applies to the result of the expression, not directly to the variable. The compiler indirectly deduces the type of pointer to array of pointer from this. Call this, as I said, the declaring an expression interpretation. It's logically equivalent to the expression recipe view, but some students find it easier to remember. And then the third alternative. One effect of the expression recipe, or declaring an expression rule, is that the order of operators in the declaration does not match the natural English order of the type description. Pointer to array of pointers to int does not translate to something like int star dim star pointer to array of pointer. Instead, the steps of the English description are applied as operators on the left and right side of the variable name, building from the inside out. Here's a diagram of that, taken from the transcript, with the words corresponding to the operators as colors indicate. So pointer to array of pointer to int becomes pointer, blue matching blue, to array, adding the bracket dim for that, of pointer, the dark blue, finally to int. What would be a left to right description becomes an inside out operator order, as later steps in the type description are added as operators outside of earlier steps. So you in effect read and write the declaration from the inside out. Avoid the temptation to try forcing the declaration into the English left to right order. This never works. Think inside out. And you now have what you need to understand any declaration that combines pointers and arrays. In the next segment, we'll extend these ideas to include functions and function pointers and their return types, and then do some exercises using the concepts.